Hello, in this math video, I will do a GED math video regarding counting. So, um, counting, this is counting, it's more like probability, more specifically combination and permutation. So, some of these word problems, will ask you, order matters, and some of these word problems where the order doesn't matter. So, that could be regarded to permutation and combination. So you're gonna go ahead and get out your notebook because we, we there will be some stuff we have to go over. So the first thing I want to go over is permutation. Okay, so permutation refers to the arrangement of objects where the order does matter. Okay, so if you know for a fact the word problem says order matters, you're gonna use permutation, and um, the formula is this: P of n comma r equals n, and then you have this little exclamation mark that means factorial, and I'll explain later what that factorial means. Um, and then it's going to be parentheses n minus r parentheses factorial. So it's really simple. It's easier than it looks. When I do an example, you'll see. But this exclamation mark means factorial. So you can put in a calculator. There is a factorial button in the calculator. Uh, but there's another way you could do it without a calculator or algebraically. Okay, so the next thing you need to know is just like what I said before, factorial notation. It would be n factorial, which represents the product of all positive integers. Okay, so here, let me show you what that means. So for example, if you had like 4 and then the exclamation mark, that's a factorial. It just means 4 times 3 times 2 until you get to 1, right? And this is actual number. If you put that in the calculator, that would be 4 times 3 times 2 times 1. That's like 24. Okay. But there's an easier way. Sometimes the number will be fairly large, like 6 or 7 or 8. You don't, you could put this in calculator, or what you could do is if you, yeah, yeah, I'll explain when we're doing a problem, but yeah. Okay. The next one refers to combination. So combination refers to the selections of objects where the order does not matter. So let's say you had C. So the formula for a combination is C of n comma R equals n factorial over R factorial times n minus R factorial. Okay, so this is when you would use this formula if uh, order does not matter. Okay, I get it clear because I'm running out of space. So go ahead and pause the video to write these formulas down because we will be using it. So go ahead and copy it down. And then just a few more notes. Uh, so in the permutation are used when the arrangement of item matters. So we said that before, but an example would be people in line or selecting winners in a race. So okay. So permutations are used when the arrangement of items matter. An example would be arranging people in a line or selecting winners in a race. And then combination is are used when the arrangement of items does not matter. An example would be uh, forming a committee or selecting a group of items from a set. So okay. So yeah, so permutations are used when the arrangement of items matter. An example would be arranging people in line or selecting winners in a race. Combinations are used when arrangement of items does not matter. An example would be forming a committee or selecting a group of items from a set. Okay, so you got the formulas down. You know when to use permutation and when to use combination, and you know that factorial signs, right? The exclamation mark means factorial, and you know what that means. You know what to do. So now we have enough information to do the three questions. Okay, I'm going to clear and start with question. So question one says, in a class of 20 students, if the teacher wants to form a committee of 4 students, so the keyword is committee. So that means we're going to probably use a combination. So in a class of 20 students, if the teacher wants to form a committee of four students, two boys and two girls, and if there are 12 boys and eight girls in the class, how many different committees can be formed? So I hear the word committee, order doesn't matter, so there's a good chance we're gonna when we I know we're gonna use combinations. Okay, so we're gonna use this formula, C of n comma r equals n factorial over r factorial times n minus r factorial. So all we got to do is figure out what is our n and what is our r. So uh, I think our n, so they're asking two boys out of 12, right? There's how many different uh how many different committees can be formed? So there's boys and girls. So let's see. Let's start with the boys. So there's two boys and two girls out of 12. So there's 12 boys, and then they want to pick two boys. So that means our N is 12 and our R is 2. So it's going to be 12 factorial. And then this would be R. So it's going to be 2 factorial. And then it's going to be 12 minus 2 factorial. So you see what I did? I now use combination. The N is the 12 is usually the larger number. The R is a smaller number. And then we're doing this for the combination of boys, right? So there's total 12 boys, so that's how I did my N is 12, and then out of two boys, so that's why my R is 2. Okay, so what do we do? How do we simplify this? So don't don't do the exclamation mark yet. Just rewrite. I'm gonna rewrite the numerator as 12 factorial for right now, and then it's 2 factorial, and then clean this up. What's 12 minus 2? 10 factorial, right? So what do I do now? So you could put it in a calculator. I have a TI. This is my. I can't show it to you, but I have a TI 30X Roman numeral 2 S. Right. In my calculator, in order to get the exclamation mark, you have to press there's a PRB button, and then click on the exclamation. Okay. Now, if you don't want to do it in a calculator, there's an easier way. Or without putting the if you can't figure how to do the exclamation mark. So what is 12? Let's do the 12 factorial and the 10 factorial, and then leave this 2 factorial alone because 2 factorial is really the same thing as 2 times 1, which is really 2. So you don't really have to worry about that. So let's do 12 factorial. So let's break it down. How do you rewrite 12 factorial? It's the same thing as 12 times 11 times 10 times 9 times 8. But I'm not going to put 9 and 8 until I get to 1. Why? Because something will cancel. Here, I'll show you. So if you did 12 factorial, it would be 12 times 10 times 10, 12 times 11 times 10 times 9 times 8 times 7, 6, 5, 4, 3, 2, 1, right? And then what about the 10 factorial? It's really 10 times 9 times 8 times 7 times 6 times 5 times 4. See what happens is the tens cancels the nines and the eight. So you really don't really need to do you could stop till 10 because everything else below cancels, right? And then you're still left with this 2 factorial, so you could either say 2 factorial or 2. Now, on the numerator, what is 12 times 11? You can easily put that in the calculator without any ease. So 12 times 11 is 132. And then on the bottom, you're left with 2 or 2 times 1, which is still 2. So what's 132 divided by 2? 66. Okay, now what we have to do is this was the boy because they're asking you how many different companies can be formed. So this was the boys. Now let's do the girls. So in the girls, there's 2 girls out of how many girls? There's 8 girls in class. So it would be 8 to 2, right? Your n is usually the larger, so it's still a combination, so it's going to be 8 factorial over 2 factorial times 8 minus 2 factorial, right? So here in the numerator, it's 8 factorial. On the bottom, what's 8 minus 2? Uh, 8 minus 2 is 7, 6. And then you have this 2 factorial. So let me clean this up. 8 factorial is 8 times 7 times 6. And I'm going to stop at 6 because on the bottom you have this 6 factorial. So this 6 disappears because everything else, if you continue, this is like 5, 4, 3, 2, 1. And then at the bottom, it's going to be the same thing 5, 4, 3, 2, 1. So I don't want to waste my time, right, to write that out. And then you're still left with this 2 factorial or 2 times 1, or really it's just 2, right? So clean it up. What's 8 times 7? 56. What's 2 times, this disappears, and then what's 2 times 1, 2? That's 28. So what you want your total, it's going to be for the boys, it would be 66 ways, and for the girls, it would be 28 ways. When you put it all together, 66 plus 28 is 94. Wait, is that right? No, no, no. You don't, we don't add them, we multiply. So it's 66 times 28, which is 1848. Okay. So in this problem, we had to use the combination formula, and for the boys, it was 12 to 2, and then for the girls, it would be 8 to 2. And then multiply out the two numbers, and that's how I got 1848. Okay, let's move on. Okay, question 2. A lock has a 4-digit code if repetition of digit is allowed, and the digit must be chosen from 0 to 9. How many different codes are possible? So, uh, this one, you don't really have to use a formula. You don't really have to use a formula. So there's how many, so from 0 to 9, how many numbers is that? So that means it's really from 0 to 1, 2, 3, 4, 5, 6, 7, 8, 9. And then how many numbers are this? So total, this is going to be, including 0, this is 1, 2, 3, 4, 6, 7, 8, 9, 10. There's a total of 10 numbers, right? So the total number of codes, so And then there's a four-digit code. So really, it's 10 times 10 times 10 times 10 because there's four digits, right? So there's a total from 0 to 9, there's a total of 10 possible ways. And then there's a four-digit code. So 10 ways for the first one, 10 ways for the second one, 10 ways for the third one, and then fourth one's 10 ways. And when you put it all together, 10 times 10 times 10 times 10 is, I think it's 10,000 or four ways. So it is D. Okay. Okay, so that's question two. Let's move on to question three. So question three says a bookshelf contains six different novels and four different poetry books. If a person wants to select a stack of three books consisting of two novels and one poetry book, how many different combination of books stacks are possible? So since order doesn't matter, we're probably going to use combination. So they're asking you how many different combination of book stacks are possible. So the number was to select two novels out of six donated as 6 to 2. So there's six different novels, four different poetry books. Which ones? So we don't care about the poetry. So there's six different novels. If a person selects a stack of three books consisting of two novels, there, so that's a big clue, it's 6 to 2, right? So it's going to be 6 factorial, 2 factorial times 6 minus 2 factorial. So it's going to be 6 factorial and then 2 factorial. 6 minus 2 is 5, 4, 4 factorial. And when you put it all together, 6 factorial is 6 times 5 times 4. If you want, you could put 3 times 2 times 1, but then that's going to cancel with the 4, right? Because 4 factorial is 4 times 3 times 2 times 1. And then the 2 factorial is 2 times 1. So the 4 cancels, the 3's cancels, the 2's and the 1's. So 6 times 5 is 30, and then 2 times 2. So whoops. Wait, did we do this right? 6 times 5 times 4. 6 minus 2 is 30. Yeah, I think I messed up. It should be on the top, I think it's 120. I think I messed up. Like I canceled something out. And then on the bottom it's still 2. So what's 120 divided by 2? 60. So there would be 60 different ways. Okay, I am gonna stop here or check my work real quick.
Perfect. Okay, I am going to stop here.